I will talk about the trigonometric identities. The trigonometric identities is a equality between expressions that contain trigonometric functions. These identities allow us to put the same expression in different way. We use the trigonometric identities when we need to simplify expression that contains trigonometric functions.
Here we have trigonometric identities that say sine x is equal to 1 on cosecant x, cosine x is equal to 1 on secant x, tangent x is equal to sine x cosine x, cotangent x is equal to cosine x on sine x, secant x is equal to 1 on cosine x, cosecant x is equal to 1 on sine x. And here identity of Pythagoras says that cosine square x is equal to 1 plus cotangent square x, and secant square x is equal to tangent square x plus 1, and the last one says that 1 is equal to sine square x plus cosine square x.
We can use these identities in conjunction with other techniques like factorization, multiplication, and others to simplify expressions that contain trigonometric functions. Here we have an example. I will to demonstrate this trigonometric identity. The way to demonstrate the trigonometric identity is transform a member of this expression by trigonometric relationships until finish the same that the other side. Here I will start with the left side. I will change tangent x and cotangent x to the trigonometric identity that we saw before. It says that tangent x is equal to sine x on cosine x more cotangent x is equal to cosine x on sine x.
And result this expression that says sine x plus cosine x on cosine x and sine x.
Next, we use identity of Pythagoras
that say that sine square x plus cosine square x is equal to 1.
We know to is the same that write 1 on cosine x and 1 sine x. And using the trigonometric identities, says that 1 on cosine x is equal to secant x, and 1 on sine x is equal to cosecant x. Here in the result, we can see that it is like the first expression. Let's continue with the topic of factorization. So we are going to say what is the factorization is a opposite process to the multiplication, and we can decompose a product in its factor. So we can say that from a result, any number, we look for the multiplication that gives rise to it. And there are different methods of factorization for some special case. There are different methods of factorization. So here we have difference of the squares, sum and difference of cubes, common factor, trinomial of x squared plus bx plus c, perfect square trinomial, and there are others, but today I'm going to explain factorization by common factor. It's the first step that we must do when we are going to factorize a polynomial. The steps are the factor must be in all our terms that form the polynomial. After we take a variable with the lowest exponent. In the case of the number, we take the biggest of the polynomial and finally multiply each one by the polynomial. We have to respect the laws. For example, the exponent law, signal law, maximum common divisor, and factor common. Here we have an example. We have 8x squared y plus 24xy at the cube, and we are going to start with get maximum common divisor. We get of the maximum common divisor 8 like a factor after we take the variables with the lowest exponent, so we can see that is x and y. Like a result, we have 8xy, and we are going to divide by each one of the terms by 8xy. So we divide each one of the terms by the common factor, and we get in the first term x, and the second 3y squared. Finally, we are going to multiply the result of the division for the factor common. After multiplication, we get the same polynomial at the beginning. In conclusion, we can see that the result is the same to the first polynomial, and we can say that the factorization was right.